Okay, we are now recording. So let's go ahead and get started. So today we are starting something new. If you guys remember last Friday, we talked about, well, the last few weeks we talked about waves. And on last Friday, I gave you guys your test to take over waves and harmonic motion. Um, this this past last class period, when I saw you guys on Tuesday, um, I discussed the instructions for your wave pamphlet, and then I'll let you guys go to complete your wave pamphlet. Remember, the wave pamphlet was a project grade. In other words, it was a test grade. So if you guys have not got that in, please do so. Please do so. Okay. Now, on today, we are starting our unit into electricity and electrical currents. So we're going to spend several weeks talking about electricity because there are all sorts of topics that are included under the electricity heading. So we're going to be talking about this a lot. Specifically on today, we're going to start talking about electrical charges. So if I go to Schoology, click on courses, we are in fifth period. Okay. I click on materials. We're in the fifth 6 weeks. Today is April the 15th, and of course it is a Thursday. Okay, so as you guys can see in Schoology, I already have the assignment posted. The assignment is already available for you guys to see, and it is titled Electrical Charges. So today we're just going to focus mainly on the concepts behind electrical charges. There's not any well, there's not a whole lot of math we're going to do today. Just a little bit of math, and I'm going to get to that in just a moment. But we're mainly going to focus on the concepts. So what I want to do, I'm going to explain a few things with you guys. Just kind of get you guys started on understanding electrical charges, and then I'm going to do a few questions on the assignment with you guys. Just so you guys understand the basics of what's going on here. And then as soon as we get done with that, I'm going to let you guys go so that you guys can finish the rest of the assignment by yourselves. Okay, so guys, if you have any questions while we're working on this, please don't hesitate to ask me. Remember, I am here to assist you. Okay, so now, before we get started with our overall topic on electrical charges, I need to review a little chemistry. So think back to chemistry. Most of you all had chemistry your sophomore year. So let's review a few things about the atom. Let's review a few things about the atom. So guys, if you think back to your sophomore year, okay, many of you guys may realize or may remember that the atom looks something like this. At the very center of our atom, we have our nucleus, right? And inside of the nucleus consists of two things. Inside the nucleus, we have protons and neutrons. And again, just so I can remind you all, remember this, that the atom is the smallest unit of matter. Everything and everyone is made of atoms. Okay, so there are protons and neutrons within the nucleus of the atom. Okay. Can anyone tell me what hovers around the nucleus? Does anybody remember? Anybody want to put in the chat box? So if we know protons and neutrons are inside the nucleus, someone tell me what goes around the nucleus. Anyone? Anybody want to tell me in the chat box? What goes around the nucleus? What do we call it? The particle that goes around the nucleus?
Electrons.
Thank you, Simon. Exactly, electrons. So if you guys remember, electrons Remember, electrons orbit the nucleus very similar to the way planets orbit our sun. So you can think of it that way, is that electrons orbit around the nucleus. Okay. Now, also I want you guys to remember that the proton has a positive charge, and the electron has a negative charge. And of course, the neutron, it is neutral, right? It is neither positive nor negative. It's just neutral. Okay. So again, this is something that you guys should have discussed in chemistry. Okay. Now, also, guys, um, if you have an atom and that atom has the same amount of protons as it does electrons, that atom is overall neutral. You know, its overall charge, or its net charge, is neutral. Okay. Now, guys, the way that we can cause an imbalance in a charge is to um, add or subtract electrons from an atom, right? If an atom has more electrons than protons, then the overall atom is negative. But if the atom loses electrons and it has more protons than electrons, then the overall charge is positive. Okay, so this is just something I need for you guys to remember from chemistry. Again, this is something that you guys already talked about in chemistry. I'm just kind of reminding you all. Okay, now, um, with that stated, it's important to know how these charges behave. It's important to know how these charges behave. So, um, guys, I want you to imagine in your minds that you have an electron and a proton right next to each other. So on my screen here, I have an electron, which has a negative charge, and I have a proton, which has a positive charge. And let us imagine that they're right next to each other. So, like, imagine just imagine that I could hold these particles in my hand, and they are right there next to each other in my hand. Now, everyone in here should know what happens if I take these particles and I release them from my hands. Can someone tell me, what do opposite charges do? So if you take two opposite charges and you set them next to each other and you release them, what's going to happen? Well, you guys may remember opposite charges attract. So if I release these two charges, eventually this is what's going to happen. They're going to attract each other, just like you saw on the screen. You kind of saw them guys. You kind of saw those um, atoms move toward each other, kind of like magnets move toward each other. So remember that, guys. Anytime you have two opposite charges always attract whenever those charges are placed next to each other. But what if you have two like charges? Well, if you place two like charges next to each other, two like charges should repel, as we kind of see on the screen here. Notice I have a negative charge here and a negative charge here. So these charges are the same. So if I place these two charges next to each other, so like if I was holding them in my hands, okay, so just kind of imagine, like, guys, imagine me holding these two charges in my hand, and then at some point I decide to release these two charges from my hand, then what would happen? Okay. So in that case, um, so right at the moment that I decide to release the two charges, this is what's going to happen. You're going to get something that looks like this, where the charges are going to fly away from each other. Did you guys see that the charges actually flow away from each other, because that's what light charges do. Light charges repel, opposite charges attract. The same thing here, guys. If I take a proton and a proton and place them next to each other, since these are light charges, they're going to also repel. So if I'm holding in my hands and I release them, they're going to eventually fly away from each other, because light charges repel, opposite charges attract. So I need for you guys to remember this important principle. Opposite charges attract, like charges repel. Okay. Um, now, um, guys, it turns out that these concepts that I discussed have some very weird implications in nature whenever we decide to do certain experiments. I want to show you guys something here. This is a really cool experiment to try out for yourselves because this experiment really shows you guys the nature of electrical charges. Okay. Guys, I want you guys to watch this video clip right here of this girl here. This girl is combing her hair. So she's combing her hair. And then after she's done combing her hair, she's going to place the comb next to a stream of water. And I want you guys to watch what happens. So notice, so she's combing her hair. Now see that? Now, in just a moment, watch what happens when she places this comb next to a stream of water. This is really cool here. Notice. Ooh, did y'all see that? Notice how as she placed the comb next to the water actually bends. In fact, while you guys are at home, I would really like you guys to try this experiment out for yourselves. It's a really cool experiment. It's really cool to see it yourself. Like take a comb your hair for several strokes, place it next to a stream of water, and you're going to actually see the water bend. Let's kind of see that again. So she's combing her hair, and she placed it next to the water, and the water bends. So the question is, guys, what's actually going on here? How is the water bending? In other words, notice how the water is being attracted to the comb. Y'all can clearly see that. And again, this is really cool to try out yourselves. Well, I want you guys to think about what's happening here. Okay. Remember what I said that like if a piece of material which is made of atoms has the same amount of electrons as it does protons, that piece of material is electrically neutral. But what happens when you shift those electrons, when you cause an imbalance in the charge? Okay. Well, guys, I want you guys to think about what's happening here. So, this young lady here, as she's combing her hair, there's friction between the hair and the comb. So, guys, it turns out that before she starts combing her hair, her comb is electrically neutral, and her hair is also electrically neutral, meaning that it has the same amount of protons as it does electrons. The moment she combs her hair, friction knocks away some of those electrons. In other words, guys, friction takes electrons from her hair and deposit them on the comb. Let me show you guys how that looks like. Let me draw a picture of this. So it's really cool that you guys see this. So here's the gear's hair. And then here's the comb. Let me kind of draw a simplified picture of a comb. So guys, what's going on here? As she's combing her hair, she's knocking off electrons from her hair, and those electrons deposit on the comb. So guess what? This comb now has more electrons than protons. It has gained electrons. So therefore, this comb now has an overall negative charge, right? So it has gained electrons. So the charge is overall negative. So since the comb has an overall negative charge, well, guess what? That's what's going to happen. When she placed the comb, hold on, guys. Yeah. So yeah, guys. So when she placed the comb next to the water, it bends because the comb now has an overall negative charge. The water molecule, what's going on here is that the negative charges on the comb are being attracted to the positive charges on the water molecule. Okay. So the negative charge on the cone is attracting the positive charges on the water molecule, and it causes the water to bend. So that's what's going on here. That's how that bending is taking place. Okay. Now, before I give you all, or before I start working on the assignment, and I give you guys some of the answers to the assignment, I want to give you guys one more fact here before we're done explaining things for the day. Here's an important fact that you guys know, because you guys have heard me say a lot about charge. But the last thing I want to do, I actually want to give a numerical quantity to charge. It turns out, guys, that anytime you have one electron, it's a basic fact here, that one electron, so one electron has a charge of negative 1.602 times 10 to the negative 19 coulombs. Okay. So C here, C means coulombs. And guys, this is the standard unit for charge. So C is the unit for charge, the coulomb. Okay, so one electron has a charge of negative 1.602 times 10 to the negative 18. So guys, that means if you had one proton, that means one proton, a single proton, has a charge of positive 1.602 times 10 to the 19. So that's an important number I need for you guys to keep in mind. That's why I'm writing it down. So obviously, if you had two protons, the charge will be double that. If you had three protons, the charge will be triple that, and so on. So this just allows us to numerically quantify charges. Okay. Now, last thing I would like for you guys to do today, before I let you guys go, I would like for you guys to go into Schoology and open up the assignment. So we are now ready to get started on the assignment. I'm going to do a few of these with you all, and then I'm going to let you guys go so you guys can do the rest on your own. So let's open up Schoology and open up the assignment. It's called Electrical Charges. So I'm going to hit Preview. Okay. All right, guys. So I'm just going to do a few of these with you guys. Right here it says, if you have 8 protons and 5 electrons, what is the overall net charge? Is it neutral, positive, or negative? So guys, y'all should know this. If you have 8 protons and 5 electrons, notice your atom has more protons than electrons. So the overall charge is positive. Okay. So the questions like these, y'all should be able to answer these questions. Again, I'm just going to do a few of these with you guys. Guys, okay, look at this. Look at this one right here. I want you guys to know how to do this one. This question right here says, what is the charge of an object that gains 3.4 times 10 to the 9 electrons? What is the charge of an object that gains 3.4 times 10 to the 9 electrons? Well, guys, in order to do this question, look at this thing right here that I just wrote down. Remember what I said? One electron has a charge of negative 1.602 times 10 to the negative 19. Okay, so that's the charge on one electron. So let me write that down. Okay, if one electron has a charge of negative 1.602 1.602 times 10 to the negative 19. Okay, so that's the charge on one electron, and we have this many electrons, and we want to figure out its charge. All we do is have to multiply, in this particular example, 3.4 times 10 to the 9, all of that multiplied by negative 1.602 times 10 to the negative 19. So guys, if y'all put that in your calculator, that should tell you the overall charge on this many electrons. Okay. I'm going to do that now. Okay, guys, when I put that in my calculator, I got negative 5.45 times 10 to the negative 10 coulombs. So that's my answer there. Any questions on what I did there? Again, I'm just showing you guys how to work out some of these problems whenever you guys get to it in Schoology. All right, let's do one more. Okay, look at this question right here. It says, what is the charge of an object that gains 1,500 electrons? What is the charge of an object that gains 1,500 electrons? Okay, well, so remember what I just said. If one electron has a charge of negative 1.602 times 10 to the negative 19 coulombs. So that means if I have 1,500 electrons, I need to take 1,500 electrons and multiply by this number to figure out what is the charge on 1,500 electrons. So let's do this. So 1,500 times negative 1.6. Okay. So guys, when I put this in my calculator, I got negative 2.403 times 10 to the 16 to the negative 16. So 1,500 electrons has that charge. Okay. And again, it's a negative charge since we deal with electrons. If this question has said protons, the charge will be positive. Okay. Any questions here? Okay, now y'all should be able to do the rest. On this question right here, if an object has a charge of 4.5 coulombs, is it positive or negative? Well, we don't see a negative there, so that means it must be positive. So let's see. Is there anything else I would want to discuss? Also, guys, on this right here where it says master work with the definitions, most of these you guys should be able to do. I just want you guys to keep in mind that I haven't mentioned this yet, but the definition of the strong nuclear force. The strong nuclear force is that's the force that keeps protons bound in the nucleus of the atom. Okay, so just FYI, the rest of them you guys should be able to do. Okay. Let's see. Okay. Guys, it should be obvious to you all whether or not an object gains or loses electrons. So here we're told that a charge has a charge of positive 4.5 coulombs. Okay, so guys, remember, if the charge is positive, that means the object lost electrons. If the charge is negative, that means the object gained electrons. So just something to keep in mind. Okay, that's pretty much all I have for that. So again, that assignment is ready for you guys to complete in Schoology. All right, guys, before I let you guys go, if you have not filled out the attendance form, please do so. Are there any questions before I release you guys? Any questions for me? Okay, so remember the Zoom call will stay open up to 9 o'clock. If you guys do have any questions for me, again, please fill out the attendance form if you have not done so. Um, um, if there are no immediate questions for me at the moment, you guys are free to go. Enjoy your day, everyone.